Welcome, ladies and gentlemen. Thank you all for being here. Let me introduce myself. I am Ken, currently responsible for sales at Applied Material Division in TSRC. It is my pleasure today to introduce you TSRC Corporation, a TPE compound solution provider. There will be two parts in today's presentation. In the first part, I will give you some background information about TSRC. We are going to take a look at our worldwide operation network. We would like to introduce the key feature of TSRC, TPE compound material, T-brand series. In the second part, our R&D specialist, Ben, will present more detail about our TPE compound material. First of all, let me give you an overview of TSRC. TSRC Corporation was founded in 1973. The company's business units are organized by function, with the synthetic rubber division responsible for the synthetic rubber products and advanced material, under supervision of our advanced material division. Through dedication and hard work in the past 48 years, TSRC has become a successful global leader in synthetic rubber and elastomer operation at 9 sites, located in Taiwan, China, the US, India, Thailand, and Vietnam. To have a clear picture, TSRC annual output of SBR, BR, NBR, TPE, compounding, and other synthetic rubber has reached 805,000 tons, and TSRC is the leading synthetic rubber supplier in Asia. Here, I would like to introduce you our worldwide operation network in more detail. As you can see from this world map, our main base of operation is in Taiwan, with our global business headquartered in Taipei. Kaohsiung also houses one of our most important manufacturing plants, at which a variety of our products are manufactured. We extended our company's reach first off to Thailand, and from there to China, where we have several production sites. Besides, our joint venture in India is followed, and our acquisition of USA Desco Polymer in 2010 enabled us to continue our success in the west of the world. Among all the production sites, TPE compound manufacturing is at 3 plants: Gangshan, Kaohsiung, Shanghai, and the Vietnam factory, which allow us to be close to our global customer and provide worldwide service. This leads to the next topic of TPE compound manufacturing. Our TPE compound global production capacity is 23,000 tons per year, consisting of 3 plants among the 3 TPE compounds production sites. Vietnam plant is our latest addition, established in October 2018, located in Binh Dua province in Vietnam, and it is also the first automation plant in TSRC. As you may already know, TSRC customized TPE compound materials contain a variety of applications, and we aim to focus our advanced shoe material development, which we have our application research center in Gangshan, Taiwan, and the main production site in Vietnam. Now, please take a look at our first automated factory in Vietnam. The auto control system greatly enhances the production efficiency. For raw material feeding, manufacturing through PLC, auto packing to the product storage through automatic guide vehicle. Each process is completed by highly automation. This is another impressive milestone achieved by TSRC, and it's humble to share the successful story with you, demonstrating our commitment and determination for continued progress. We welcome your participation to become our business partner, joining together for a successful venture. Next, beside our automated production base, here I would like to give you a brief about our TPE compounding material, T-brand series. TSRC is vertically integrated under TPE material, TPE, covering a full range of SBC products, complementing a total solution with our T-brand series, which is a is SEBS compound material compatible with EPDM or EVA. T-brand helps to realize new design possibility and add value to improve product feature. Next, the features of TPE foam compare with traditional EVA, POE, and TPE foam. TPE compound foam have excellent performance in terms of specific gravity, hardness, compression set, resilience, anti-slip, and weather resistance. Here are several key applications of TSRC T-brand, which is with high-tech elastomer compound material. First, T-brand Prime foaming product. Its simple formulation offers wide operation window to achieve various product features. Second, T-brand injection and overmolding materials offer attributes such as product comfort, self-handling, resilience, durable, and aesthetic feature, and make new design possible. Last, T-brand ASN series, a premier SEBS compound for footwear, all-in-one product. This is related to the point I mentioned in the former page. The wide range of T-brand helps customers to realize new design and add value to improve customer product features. I hope now you have a clear picture of our service. Now, let's move on to our next session. My R&D colleague Ben will give you more detail about our T-brand materials.
Thank you, Ken. I will take over to introduce the technology part. Foaming properties of SEBS foam are superior to those of traditional EVA foam and have the performances of anti-slip and wear resistance, shockproof and highly flexible, low temperature resistance and recyclable, also with the benefits of wider processing window, no rubber udder, and ease of color mixing. Can be molded into wide variety of shapes and as a modifier for rubber or plastic foam products. T-brand foaming products are highly compatible with EPDM, EVA, and SBR. They can simplify formulation and provide wider processing window. T-brand offer improved properties and have excellent performances than EVA and TPU foam. Here are 3 examples of our existing T-brand products, including hardness of 40, 47, and 60 show air. They feature hardness reducing, increasing soft touch, and high rebound performance. Here shows one example of applying 60% of T-brand foaming modifier with 40% EVA. It improves elongation up to 400%, stiffness as tensile strength up to 30 kg per centimeter square, speed tear more than 2.5 kg per centimeter, compression set less than 50%. It is also soft touch with excellent flexibility and high resiliency more than 60%. Here are some examples of foaming applications: slippers, yoga mat, and as EVA midsole modifiers for shoes. Overmolding is a 2-part process in which the thermoplastic elastomer TPE is directly injected onto the plastic component. The thermoplastic elastomer can be designed according to different functional requirements, such as soft touch, vibration reduction, anti-slip, and so on. The benefits include removal of adhesive step, no surface preparation needed, reducing costs, and also environmentally friendly. TSRC's overmolding products include PP, PE, PS series, as well as engineering plastic overmolding products, such as the applications of ABS, and PC. They provide comfort, anti-slip, aesthetics, and different hardness for the customers to choose from. New technology breakthroughs are the overmolding with hardness lower than 40 short A or greater than 80 short A. These products are comfortable, also have passed sweat resistance tests, making them very suitable for body-worn device applications such as eyewear and smartwatches. In addition, TSRC has also developed products that can directly inject it onto PET cloth without additional coating of adhesives, which is helpful for automated production. This slide shows some overmolding applications such as bicycle pedals, hand grips for game controller or bicycles, and hand tools. Our products in footwear industry perform well, especially in lightweight, high energy return, balanced mechanical properties, and they are also eco-friendly. Lightweight foam provides less weight and more stability. High performance provides excellent and balanced mechanical properties for different sports. High energy return provides enough support for the feet. Green is to provide eco-friendly solutions. Here are 4 products for footwear applications, including hardness 45 short C for running shoes and hardness 55 short C for basketball shoes. Each product features lightweight under than 0.2, high resiliency more than 55 to 60%, stiffness of speed tear more than 2.5 kg per centimeter, and good compression set less than 50%. In order to cherish the Earth's resources, we would like to provide eco-friendly solutions by using biomaterials. We introduced green EVA, which is an 80% sugarcane-based ethylene with 30 to 60% of bio content to maintain critical physical performances with no additional processing or operation time, and product portfolios can be expanded. To satisfy green requirements, we apply 20% of bio content in our existing footwear foams. Key physical performances can remain at the same level, including specific gravity lower than 0.2, rebound more than 55%, speed tear more than 2.5 kg per centimeter, and compression set less than 50%. Let's move to Ken again to introduce vision of advanced shoe materials and the final conclusion.
Thanks, Ben. Especially in footwear business, TSR's vision is to become one-stop shop for footwear. SBC-based material used in sports shoes integrate top to mid-down technology. Sustainability is our developer goal to carry out one-stop material design service for our customer. Here, I would like to sum up the main aspect of TSRC T-bird materials. TSRC is an innovative total solution provider with extensive application, including modified, overmolding, and customized footwear material. Modified material, simplified formula, manufacturing process, and offer various features which can enhance the performance of soft touch, excellent flexibility, and resilience. Overmolding materials make product comfortable, safe, resilient, durable, and appealing, which can be used on PA, PC, PE, PS, and ABS. Footwear materials have outstanding performance, including superior rebound with stable sustaining effect, high impact absorption, It helps realize new design and add value to customer products. Thank you all for your attention, and I hope you enjoy our presentation. Good news is that TSRC product is now available on Alibaba. You may search TSRC on Alibaba or click the link below. Transformational chemistry transforms lives. TSRC is your partner as always.
Hello everyone, welcome to TSRC online webinar. The topic today is about TSRC's innovative SEBS products. I'm Simon Huang from TSRC Global Marketing Department. We are glad to have the chance for sharing the progress of TSRC's new SEBS product with you today. After this meeting, if you are interested in further cooperation with TSRC, please don't hesitate to contact us offline. The presentation will be shared by me and Norman Huang, the Project Manager of Technical Service Department. Norman, could you introduce yourself?
Hello everyone, my name is Norman Huang from Technical Service, TSRC. My job is to evaluate the performance of SEBS and compound ingredients, as well as study formulation for various applications.
Thank you, Norman. The presentation will be divided into several parts. The first part is TSRC's global distribution, including sales, R&D, and the production sites. TSRC is a global company with sales representative with technical service team in Asia, Europe, and the Americas. Then, we will move to our major topic today, the innovative SEBS. In addition to the general SEBS grades, TSRC continue to make efforts in developing new products. In recent years, we have observed that there are some products such as high flow SEBS and high oil absorption SEBS have drawn massive attention in the compounding market. So we have developed a series of SEBS products to meet customers' needs. In the later slides, we will share the features and applications of TSRC's new SEBS products, including high flow 6014, high vinyl low styrene DP6245D, high vinyl DP6240, and ultra high molecular weight with low styrene DP029. First of all, I would like to briefly introduce TSRC company. Our company was established in 1973. In the beginning, TSRC started business from synthetic rubber, such as SBR, BR, and then developed TPE product line as another core business. The registered headquarters is in Kaohsiung, Taiwan. There are 1,700 employees and 9 production sites around the world. We expect to provide efficient service and local supply to our customers. TSRC's production sites are mainly in Asia, including Taiwan, China, India, Thailand, Vietnam, etc. Outside Asia, we also have production sites in Plaquemine, USA. In addition to production sites, there are plenty of sales and technical teams in the 3 regions of Asia, Europe, and the Americas to serve local customers. Regarding TPE business, TSRC's main production sites are in Taiwan, China, and the US. Among them, SEBS production sites are located in Nantong and Kaohsiung. TSRC also possesses Global Application Center in Shanghai, China, and Gangshan, Taiwan, to provide technical support to downstream customers. TSRC medical SEBS, such as Vector 8101 and the DP6245D, are both produced in Nantong production line. This production line is supplied based on medical GMP production standards. The packaging area is equipped with a class 100,000 clean room to provide stable and reliable quality. TSRC's commercial grades could be classified as shown on the slide. As you can see, low molecular weight grades such as 6014, 6150, 6152, 6153 are commonly used in applications like film, packaging, adhesives, and plastic modification. As to the higher molecular weight 6151, 6154, 6159 can be used for general compounding and plastic modification. Certainly, this table only provides a preliminary reference. Users still need to adjust the formulation according to their specific requirements. In addition to the general grades, typo 7131 and 7126 and grafted SEBS are suitable for overmolding and the modification of engineering plastic like nylon. The medical grade 8101 is produced based on the medical GMP standards, which has strict quality control, and the ash content is below 0.1%, suitable for medical applications such as medical stopper, liner, PP closure, syringe tip, etc. For the following slides, Norman will share TSRC new SEBS products, features, and suitable applications.
Thank you, Simon. First of all, I would like to briefly introduce the relationship between current SEBS grades and new developed grades by using 3D product map in this slide. TSRC provides conventional SEBS grades including 6152, 6150, 6153, 6154, 6151, 6159, etc., ranging from low molecular weight to ultra-high molecular weight. We also provide MA grafted SEBS 7131 and 7126, which can be widely used for overmolding and engineering plastics modification. For new developed SEBS grade, such as 6014, DP6245D, DP6240, DP029, and medical grade Vector 8101. Besides molecular weight, we also adjust two another parameters, vinyl content and styrene content, to design new products. Allow me briefly introduce how vinyl content and styrene content influences the property of SEBS. When the vinyl content is higher, the flowability of SEBS will increase, and the compatibility with polyolefin and transparency will increase as well. The hardness goes down. When the styrene content decreases, the hardness will decrease as well, and the compatibility with polyolefin will be better. By using those three parameters, we can design differentiated SEBS product to provide to compounder or end users for their demand. Firstly, I would like to introduce 6014. From this map, you can find that 6014 has low molecular weight and low styrene content. Compared with conventional SEBS, 6014 has higher flowability. The melt flow index is about 4 to 6 at 230 centigrade, which means 6014 can be processed without extended oil. With good physical properties and toughness, 6014 is suitable being applied both in room temperature and lower temperature environment. Next one is DP6245D. It is low styrene and high vinyl content, which is capable to make transparent compound. Same as 6014, DP6245D can be processed without oil as well. It is suitable for medical applications like medical tubing or medical film, and the products that oil is not desirable. Additionally, DP6245D is also suitable for food contact application or plastics modification. The third new product is DP6240. DP6240 has higher molecular weight and higher vinyl content, which means DP6240 has better flowability and processability, which is suitable for injection molding of large parts. The last one is DP029. DP029 has a lower styrene content and ultra-high molecular weight. It has highest molecular weight among TSRC SEBS products. This kind of structural design has a longer middle EB block, which makes TPE-29 an excellent oil absorption and oil holding product. It is suitable for high oil extended applications, such as soft toys. So next, I would like to give detailed introduction to each new developed SEBS grade. The first one is high flow SEBS 6014. 6014 is new developed SEBS with higher flow ability and lower styrene content. The molecular weight structure is shown in this slide. Compared with current SEBS grade, the polystyrene blocks on the two ends of molecular chain are shorter, and the middle EB block is longer. The structural design allows 6014 to be processed without extended oil. The melt flow index is about 4 to 6. 6014 is suitable blending with other plastics or elastomers, such as PP, PS, POE, etc., which means it can be used in different types of process and various applications. In addition to higher flowability and lower hardness, 614 also shows excellent impact resistance at low temperature. The detail of impact resistance will be introduced in later slides. The table in the slide shows some basic properties of 614 compared with current grade. As you can see, the styrene content of 614 is lower. It's about 18%. And the hardness of knit polymer is lower as well. It's about 78. With higher flowability, 614 can be applied to plastic modification, general compound, cable, and film applications. Because 614 has special structural design, it brings features like high flowability, easy processing, etc. 614 is suitable for use in various applications. For example, yoga band for exercise. 614 can help reach better elasticity. 614 can also use in car bumpers or interior parts in automotive applications. It can enhance the effect of impact resistance. The other example is using in adhesive for modification. In addition, 614 can also be used in flame retardancy application. Replace certain portion of extended oil, it can reinforce the effect of the flame retardant so that flame retardant can be used less, saving the total cost. As mentioned earlier, 614 can be blended with plastics or elastomers in compound formulation. We know that flow is key factor. Huge differences of flowability may cause many problems in processing or end products, such as unstable extrusion, dispersion unevenness, or patterns on end products. The figure in this slide displays capillary rheology in 230 centigrade. You can find that 614 has close flow property to some common plastics or elastomers, like PP or POE. From low shear rate to high shear rate, 614 has similar shear viscosity to those general purpose plastics and elastomers, which indicates that no matter what kind of process is, 614 is workable with other ingredients. As we discussed earlier, one major feature of 614 is excellent impact resistance. Next, I would like to show you the impact resistance of 614 in PP modification formulation with ISA impact testing method. In ISA testing method, there are 4 breaking modes after specimen being impacted. There are complete break, hinge break, partial break, and non-break. You can imagine that the non-break specimen has the best impact resistance, whereas the complete break has a poor impact resistance. The performance of 614 as modifier is shown in the table. Here, we will also choose competitive grades A and B for comparison. You can notice that both of knit polymer and 10 pHr of SEBS show complete break after impact at room temperature, which indicates poor impact resistance of both groups. But when 614 raised to 20 pHr in formulations, breaking nodes turns from complete break into non-break, while competitive grade A and B are in partial break. It shows that 614 can achieve good impact resistance at room temperature by adding 20 pHr in PP, while competitive grade have to add 30 pHr to reach the same performance, which indicates that 614 is an excellent toughening agent and a cost-effective SEBS grade. In addition, filler is often used in compound formulation to enhance certain physical properties or reduce cost. In those formulations, 614 can also achieve good impact property. Also, besides room temperature, impact property under low temperature environment is the focus of compounder or end user in some applications, such as automotive. The figure in this slide shows impact resistance of modified PP with torque and modified PP without torque. Both figures suggest that whether layer is torque or not, having 20 pHr of 614 can greatly increase the impact resistance at room temperature, while at low temperature -30 centigrade or -40 centigrade, having 30 pHr of 614 can also achieve the same impact resistance performance. It indicates that 614 is not only a good toughening agent, but also a team player in a multiple ingredients formulation. In previous slides, we suggest that 614 can compound with elastomer to enhance overall elasticity of formulation. Here, I would like to show you an example in automotive applications. In this automotive part, we use 6% of PP and 20% of torque. And we also have 20% of POE to make it tough. In this 20% of POE, we try to mix with some 614. By changing the ratio of POE and 614, we want to observe how 614 can assist POE to become more tougher at low temperature. As shown in this figure, we can see that 20% of POE can effectively improve the impact strength at low temperature. But with the addition of 614, from 5% to 10%, the impact strength can furtherly increase, which indicates that 614 is not only an excellent toughening agent itself, but also assists to enhance overall impact strength with POE at low temperature. Next, I would like to introduce high vinyl and low styrene SEBS DP6245D. With a special structural design of high vinyl and low styrene content, DP6245D is featured by its high transparency and low hardness. Just like 614, DP6245D can be processed without oil and has good compatibility with PP. It is suitable for high transparency and high quality products, such as IV bag and IV tubing in medical goods. DP6245D can also be used in plastic modification, food contact, packaging, and hygiene application. In compound formulation, it is convenient to utilize DP6245D to adjust hardness. A wide range of hardness is achievable by compound with DP6245D. In this slide, we blend different portions of DP6245D in PP. You can see that the hardness range can be reached from 60D to 48. It is demonstrated that DP6245D is an excellent choice at adjusting the hardness without extended oil, which is beneficial to those applications where oil is not desirable. It can also avoid problem of oil bleeding or migration. DP6245D provides flexibility of ingredient selection of formulation and wide ranging of hardness. In addition, as mentioned in previous page, one of the features of DP6245D is that it is easy to process without oil. From rheology on the left, the odor-disorder temperature is about 240 centigrade, which means DP6245D can reach to ideal processing condition over 240 centigrade. The capillary rheology on the right shows the flow of DP6245D is similar to PP. The shear viscosity is close to PP, no matter whether it is under high shear rate or low shear rate. Another important feature of DP6245D is the high transparency, which makes TP6450 a great choice for high transparency goods, such as film, tube, or others, which clarity is necessary to see it through. Besides, blending TP6450 with some kind of PP can improve transparency. As shown in this slide, when TP6450 increases, the transparency also increases as well. It could be contributed to the good compatibility of TP6450 and PP. In the TEM figure, the black dot is TP6450 and the white region is PP. You can find that TP6450 can uniformly disperse in PP, which indicate uniform physical property and better transparency. We also compare TP6450 with competitive grade. From this slide, you can find that regardless of physical properties, color, or flowability, TP6450 had the same performance to competitive grades. Next, I would like to introduce high vinyl SEBS TP6240. Just like TP6245D, TP6240 is high vinyl product. Vinyl content is 60%. The differences between TP6245D and TP6240 is that TP6240 is high molecular weight. The molecular weight is similar to current grade 6151. Styrene content is 32.5%. This kind of high vinyl, high molecular weight structural design allows TP6240 having better flowability, processability, and transparency, while maintaining certain mechanical properties. Compared with 6151, high vinyl TP6240 is softer. The hardness can be reduced by 10A in compound formulation. It can be applied to wire and cable, plastic modification, and general compound. Here, we test the hardness of TP6240 with the current grade 6151 in a basic testing formulation, as well as blending each half. You can see that the hardness of TP6240 is less than 6151, about 10A, and the hardness of the blend is in between. From different perspectives, TP6240 can use less extended oil to achieve the same hardness as 6151, which makes TP6240 more suitable for some applications require low oil bleeding or high flame retardancy. As mentioned in previous pages, the high vinyl TP6240 has a better flowability. From capillary rheology or spiral flow test, the shear viscosity of TP6240 is lower than 6151, and flow length of TP6240 in spiral flow test is longer than 6151 under different injection pressure, which demonstrates that TP6240 is especially suitable for large part injection molding, thin wall injection molding, or other compound method require higher flow. In customers' feedback, they also recognize that TP6240 has higher flow, lower hardness, and better transparency. The surface of injection part has a better touch and less flow lines. In the last part of newly developed SEBS, I would like to introduce ultra-high molecular weight and low styrene content SEBS, TPO29. TPO29 has ultra-high molecular weight. The molecular weight is about 1.5 times to high molecular weight 6151, and the styrene content is less than conventional grade. It's about 23%. This kind of low molecular chain but shorter end block design makes middle EP blocks longer, which enable TPO29 have best oil absorption capacity among all SEBS grades. It is especially suitable for high oil extended formulation and capable of having drier touch and less oil bleeding. Compared with current grade 6151 and 6159, TPO29 has outstanding oil absorption capacity and less oil bleeding. With lower styrene content and longer middle EP block, TPO29 brings more resiliency. And because it is ultra-high molecular weight, TPO29 is capable of maintaining compression set without suffering from lower styrene content. In fact, comparison set of DP029 is still better than high molecular weight 6151. Here, we use a basic formulation to evaluate the performance of DP029. The formulation includes low oil content formulation A and high oil content formulation B. We would like to see the property of oil absorption capacity, oil bleeding, and comparison set. As mentioned in previous pages, compared with 6151 and 6159, DP029 has excellent oil absorption property. In this slide, we test the oil absorption capacity of neat SEBS powder by immersing SEBS into oil with different time. Let's say 1 minute, 3 minutes, and 5 minutes. Then we calculate the weight differences before and after immersion. From the test result, we can see that no matter what the immersion time is, DP029 absorbs the most oil. The test results suggest that DP029 has better oil absorption performance than the conventional grade. In addition to oil absorption capacity, DP029 also has outstanding oil holding properties, which means it can bleed less oil. In this test, we put the injection molded sample contact with cardboard at 70 centigrade for 72 hours and calculate how much weight is lost. Clearly, the weight loss is due to bleeding oil absorbed by cardboard. From the test result, you can find that in low oil formulation A, the weight loss of each grade have no differences. However, in high oil formulation B, it is obvious to notice that DP029 has less weight loss. The test result indicates that DP029 is capable of bleeding less oil and showing better oil holding performance. Finally, we would like to compare the comparison set. We know that comparison set and styrene content are closely relevant. Lower styrene content may increase the comparison set. Although DP029 has lower styrene content, the ultra-high molecular weight design can compensate the shortage of styrene content. From the figure, we can find that regardless of low oil content or high oil content, the comparison set of DP029 is still better than high molecular weight 6151. To briefly summarize, the general SEBS grade is gradually unable to meet the requirements of new downstream applications. The market desires new SEBS polymer to develop new value-added products. As leading company of elastomer, TSRC proactively cooperates with downstream customers to provide high-flow, easy processing SEBS products such as 6014, DP6245D, DP6240. Moreover, if your products require higher impact strength, you can choose 6014. If your products require high transparency, you can choose DP6245D. If your products require high physical properties and use in large parts or single injection molding, you can use DP6240. If your products require high oil extent without risk of oil bleeding, DP029 will be your best choice. All of the products mentioned have passed the full content FDA test as other commercial grades. They are reliable and safe to use in diverse end products. That's all for presentation today. Thank you for your time, and if you are interested in more cooperation with TSRC, we are looking forward to receiving your messages. Thank you.
Hello everyone, welcome to TSRC online webinar. The topic today is about TSRC's medical solutions. I'm Simon Huang from TSRC Global Marketing Department, mainly responsible for the medical market development. I'm glad to have the chance for sharing the progress of TSRC's medical solutions with you today. After this meeting, if you are interested in further cooperation with TSRC, please don't hesitate to contact us offline. This presentation will be divided into several parts. The first part is TSRC's global distribution including sales, R&D, and production sites. TSRC is a global company with sales representative and a technical service team in Asia, Europe, and the Americas. Then, we will move to our major topic today, TSRC medical focus and the solutions. In addition to general SEBS grades, TSRC continue to make effort in developing new products. In recent years, we have observed that medical market has drawn massive attention in the elastomer market. So we have developed a series of medical SEBS products to meet customers' need. Medical market has been the focus of TSRC since many years ago. This market requires high product quality and consistency. Therefore, TSRC put a lot of resources in R&D, manufacturing, quality control, in terms of software and hardware to provide reliable raw material. First of all, I would like to briefly introduce TSRC company. Our company was established in 1973. In the beginning, TSRC started business from synthetic rubber, such as SBR, BR, and then developed TPE product line as another core business. The registered headquarters is in Kaohsiung, Taiwan. There are 1,700 employees and 9 production sites around the world. We expect to provide efficient service and local supply to our customers. TSRC's production sites are mainly in Asia, including Taiwan, China, India, Thailand, Vietnam, etc. Outside Asia, we also have production sites in Plaquemine, USA. In addition to production sites, there are plenty of sales and technical teams in the 3 regions of Asia, Europe, and the Americas to serve local customers. Regarding TPE business, TSRC's main production sites are in Taiwan, China, and the US. Among them, SEBS production sites are located in Nantong and Kaohsiung. TSRC also possesses global application center in Shanghai, China, and Gangshan, Taiwan, to provide technical support to downstream customers. TSRC medical SEBS, such as Vector 8101 and the DP6245D, are both produced in Nantong production line. This production line is supplied based on medical GMP production standards. The packaging area is equipped with a class 100,000 clean room to provide stable and reliable quality. Next, I'm going to share with you TSRC medical solutions and our focusing applications in the following slides. Currently, TSRC is primarily focusing on 4 types of applications. The first category is the film applications, such as IV bag film, surgical drape, and so on. These products could use blown film or casting film technology as foaming process. The second category is tubing applications, such as IV tubing, oxygen tubing. The third category is stopper, such as medical stopper, liner, PP closure, syringe tip, and other sealing materials. The last category is soft touch materials, such as ambu bag, mask, tourniquet, which contact with the skin only. TSRC medical SEBS has passed 10993-5 test and the USB Class 6 test, which are crucial for medical raw materials. It does not contain aromatic plasticizer and is based on medical GMP management. It is also an environment-friendly material. There are 2 major product series for medical applications. The first one is the high vinyl DP6245D, which is under development. DP6245D is a high vinyl and a low styrene polymer. The product feature is high transparency and a low hardiness. It is suitable for IV bag film, CAPD bag film, and IV tubing, medical tubing, etc. The other series is Vector 8101, 8103, 8104, which have been commercialized. The series products have low ash content below 0.1% to meet medical pharmacopoeia requirements. Suitable for PP closure, medical stopper, liner, and syringe tip, and so on. First, I would like to introduce Vector 8101. 8101 can be used in plastic modification and TPE compound application by formulation design. The required hardness can be obtained by adjusting the ratio of PP, SEBS, and the extended oil, which has a good performance to improve impact strength. As you can see from the table, when 70% of PP blended with 30% of 8101 and the extended oil, the hardness of PP 67D can be reduced to under 58D in proportion to oil content. And the impact strength increases from complete broken to non-broken. The starting formulation is often used for inner and the outer TPE closure in IV set. Regarding TPE compounding applications, when 100 pHR of 8101 blended with 100 pHR of extended oil plus 40 pHR of PP, the hardness can be significantly reduced to 63A. This starting formulation is commonly used as a medical stopper, liner, and so on. China YBB regulation of PP closure indicates that the inner cap must be tested by 18 gauge needle, and the amount of piercing residue must be less than 20. Of course, the piercing residue is lower, the better. We found that when PP is 70%, 8101 is 24%, and the extended oil is 6%, this formulation could achieve zero piercing residue. We also found that this amount of piercing residue is related with the impact strength. When the impact strength is higher, the amount of piercing residue is lower. Therefore, the impact strength is also an important indicator to PP closure. Of course, this formulation is also just a starting formulation, which can be adjusted according to the user's need for other physical properties. Next, we will discuss the application of 8101 in medical stopper and liner. The hardness of common medical stopper is around 40A. Then we can also adjust the ratio of SEBS 8101, PP, and the extended oil to make the hardness range 35 to 50A to meet the needs of different physical properties. According to our data in the lab, these four formulations of different hardness all have good compression set and good physical properties. After steam sterilization at 121 centigrade for 30 minutes, we found that the physical properties have no significant change. So they are very suitable to be used as alternative material to butyl rubber or isoprene rubber. In addition to physical properties, medical stopper and the liner have several important indicators in China YBB regulation, which are penetration forces, penetration residue, self-sealing, and the needle retaining performance. When it is used on the medicine bottle, it needs to be tested by 0.8 millimeter metal needle. And when it is for IV bag or IV bottle, it needs to be tested by 5.2 millimeter plastic spike. According to our lab data, these formulations are able to achieve good performance for these important indicators, no matter for metal needles or plastic spikes. The piercing residue is 0, the self-sealing is great, no leaking is observed, and the needle retaining performance is also good. There is more data not shown today. If you are interested in more details, please feel free to contact us after the webinar. In the next section, I will briefly introduce the two medical applications of TP6245D. The first one is about medical tubing, and then the second one is about IV bag. Due to its high transparency, TP6245D is suitable for various medical tubing applications, such as IV tubing, oxygen tubing, CAPD tubing, device tubing, and so on. According to different formulations, it can be adjusted to different hardness. Here are a few starting formulations for your reference. Common tubing hardness are 60A, 70A, 80A, and 90A, which can be adjusted by the ratio of SEBS TP6245D and the PP without oil extended. Generally speaking, 60A and 70A are commonly used in IV tubing applications, while 80A and 90A are commonly used in oxygen tubing. With lower hardness, the TP6245D ratio will be higher, which will generate higher transparency. All of these formulations could perform good physical properties. In addition to physical properties and transparency, there are two important indicators that are often monitored. The first one is kink resistance. When the value is lower, less kink will occur, which means liquid or gas transportation will be more reliable. The second one is a clamp resistance. Since IV tubing often use roller clamp to control the flow rate, when the value of clamp resistance is lower, medical tubing could quickly recover after the roller clamp is removed. In other words, less tubing clogging will occur. As you can see our lab data, two thinner tubings are tested because the thinner tubing is more likely to kink and clog. The two tubings are 4 mm outside and 3 mm inside. The other is 2 mm outside and 1 mm inside. From the table, we can see that the values of different hardness have similar and good testing results. We further compare with commercial PVC medical tubing. The hardness of the PVC tubing in the experiment is 67A, so we compared with TPE tubing at 60A and 70A. From the table, we can see that the specific gravity of the TPE tubing made by TP6245D is lower, which means it has advantage of lightweight. Besides, tensile strengths are quite similar as well as kink resistance and the clamp resistance. So the tubing made by SEBS TP6245D is very suitable to be the alternative to PVC tubing. In addition to physical properties, sterilization is also a very important procedure in medical applications. There are several common sterilization methods, such as steam sterilization and gamma radiation. The common concern of raw material is whether the physical properties will deteriorate after sterilization. Therefore, we compare the physical properties after sterilization in our lab testing. In the test, tensile strength, elongation, and the yellowing index of the compound were compared after steam sterilization and the gamma radiation. The compounds are made by different ratio of SEBS TP6245D and the PP. The steam sterilization condition is 121 centigrade for 20 minutes, and the gamma radiation is 25 kilograms. First, let's look at the tensile strength comparison. The blue line is a value measured before sterilization, and the red line is a value measured after steam sterilization, and the green line is a value measured after gamma sterilization. From the figure, the data before and after steam sterilization and the gamma sterilization are basically very close, and there is no obvious gap. Next, look at the comparison of elongation. We can see there is not much difference after gamma sterilization, but the elongation increases after steam sterilization, especially when the SEBS ratio is relatively higher. Lastly, let's see the comparison of the yellowing index. After steam sterilization, there are about 3 points increase of yellowing index value, but the difference is not obvious. Unlikely to observe the differences by naked eye. After gamma sterilization, when the SEBS DP6245D ratio is over 30%, the yellowing index is very stable without any change. However, when DP6245D ratio is under 30%, the yellowing index after gamma sterilization increases significantly. So we recommend, if users' sterilization equipment is gamma radiation, the ratio needs to be adjusted to blend more than 30% SEBS DP6245D to avoid yellowing issues. In the next section, I would like to introduce the application of DP6245D in IV bag film application. As you know, the most common IV bag film on the market is a 3-layer co-extruded film or 5-layer co-extruded film. Here is an example of typical 3-layer film. Each layer has different function. The outer layer must have heat resistance and scratch resistance. And the middle layer must be flexible and transparent. And the inner layer needs to have low temperature sealing capability and high sealing strength. Generally speaking, the thickness of the middle layer is thicker than other layers to ensure its flexibility and transparency. The typical thickness of a 3-layer co-extruded film are 180 micron, 200 micron, 240 micron, etc. From our lab data, we can see that besides good physical properties, the material has a very good transmittance, which means high transparency. In addition, haze and the yellowing index are quite low. The water vapor transmission rate and the oxygen transmission rate are also very good, which will be explained in the following slides. One of the important indicators of IV bag film is the heat sealing strength. When the sealing strength is high, the risk of broken bags can be reduced. According to China YBB regulation, the heat sealing strength of IV bag must be higher than 25 Newton. We found that the heat sealing temperature will affect the sealing strength of the finished product. Therefore, we test the sealing strength from the sealing temperature of 140 centigrade to 190 centigrade. As we can see from the chart, when the heat sealing temperature reaches or higher than 160 centigrade, the heat sealing strength will be significantly improved. Then comply with China YBB regulation. Therefore, we recommend that the heat sealing temperature be set at 160 centigrade or higher in sealing process. Another important indicator of IV bag is the water vapor transmission rate, WVTR, and the oxygen transmission rate, OTR. to ensure the stability of the infusion solution and avoid being polluted by the external environment. According to YBB regulation, the WVTR must be under 5 gram, and the OTR must be under 1,200 millimeter. We use SEBS DP 6245D blending with PP to produce 4 types of thickness IV bag film, 180, 200, 220, and 240 micron. Then measure the values of WVTR and OTR. From the test data, we can see no matter which thickness it is, it has excellent water vapor and oxygen barrier. Therefore, they are suitable to apply in IV bag film applications. That's all for my presentation today. Thank you for your time. And if you are interested in more cooperation with TSRC, we are looking forward to receiving your messages. Thank you.